Good afternoon from my side. So if we are a little bit ahead of the schedule, perhaps I can fix that. So a couple of words about the scalability of the digital twins to the company operations. We have heard quite a bit about these research projects and the concepts that we have there under development and in quite good condition already, but we have still a couple of steps to take to really turn this to real business. And I tried to take a couple of enablers up here which are needed to do the scalable change there. And there also I'm able to list a couple of challenges what we need to overcome before we are there. So first, the potential to scale the DTs for company operations, couple of things over there, and after that the challenges over there. In the end, I have got a kind of summary also. Somehow I see that what we need to have there to put all this in practice to daily life in the companies is just to have IoT strategy there on the background. The strategy is something that is kind of like the means and tools to make something happen. And this is like the base element to make the implementation of the digital twins easy enough or like a plug and play type of thing. It cannot be any project, implementation project for each and every digital twin in the company. If it's going to be too time consuming and too costly to make the implementations one by one, the whole idea is going to die out. But rather, it should be like a process. It should be an easy thing to create the digital twin and make it operational for each and every delivered item or product. So we need to have the strategy there on the background that is defining that how we are actually organized to get this happen easily. And this needs to come to the level that how the digital twins are actually created and how they are maintained once time is flying and the digital twins are there in the customer's hands. We also need to define there in the IoT or digital twin strategy that which are the requirements for all of the new developments coming from the strategy viewpoint, because their background system, the system where we collect the information, where we do the analysis, where we do all the reporting and we actually utilize the information, needs to set up some kind of requirements for the developments. If the developments are not aligned to this background system, they are not able to behave in this framework as they should do. We need to go also to the level of the data sets, to their formats, and define that what are the guidelines and directions where to go in the developments to be all the time compatible with this, I would say, fairly massive background solution that we have there to really analyze the data in volumes. And also what we need to define there in the IoT strategy is that what is actually our aim to utilize the information. If we do not have scenarios existing, it's very difficult to target the solutions to create that information what's needed for the known business purposes. So it's better that this is also written down what are the main focus areas to utilize the information, and like that direct all the actions done in the company to the same direction to serve the business need. And also in the IoT strategy, it's very, very, very important to define that who is actually running the show, which organization is responsible to actually drive all the research and development to the actual implementations to the daily business operations. If there is not that kind of like defined person and responsibility, I believe we are going to fail anyhow. The action gets fragmented in the time, and sooner or later we don't know where to go and who actually should be the person to be measured about the result. One important thing additionally to the strategy is the let's say alignment and landing of the digital twins to the company IT solution. Typically in the larger companies the IT solution is fairly complicated, and once digital twins are collecting information during their lifetimes from many of the source systems, handling their product from the sales to the after sales level and all what's there between the supply systems, the like PLM systems, the like service management systems. So it needs to be done that how the digital twins are landing to this landscape of those different systems. Also remembering that we have this life cycle aspect there, but then we have also the functional aspect. That means basically those simulations of the cranes or equipment there on the field, and that also means the like structural data and design and validation information. All they should be also connected to support the information that we then fetch from the real world to understand better that what does this real world information really means. So if I have kind of like information that some brake is giving me some signals, in the other hand I need to have the information of the structure of the brake. Which kind of item specific brake I have there in this crane. If I don't have it, the information is partly meaningless. What could be then the system to maintain the asset master, if we call this system or data storage so? That is kind of like owning the connections from this asset to the different systems, collecting information from the equipment during its life cycle, and also having the linkages to the functional model. I believe that it could be easily PLM, because at least we have the requirements for these systems managing the digital twins and assets, like that it needs to be long term, it needs to stay there as long as the equipment on the field. We speak easily from 10 to 30 years. We need to have such a system that is globally used. Typically in the system that is mastering the digital twins should be close to the design information of the digital twins to be able to serve that data for the persons who need to analyze better that what's actually happening there around the equipment. So like that, I would say it's potential to have the PLM there mastering the assets. Where we then could use and can use the information once it's available. First we could have a look to the information. Actually we have there on the background the let's say equipment, pieces of equipment on the field, and they collect their information to the digital twins, having their product structures, having their 3D models, perhaps kinematic 3D models, having perhaps their indications that are showing that how each and every component there in their structure is doing. But this is one aspect to the thing. Then typically if you want to analyze the information for the purposes of the new product development, that is one very potential area. We need to have kind of like larger view to the information. We need to collect the information together from many similar cranes in the or equipment in the same kind of customer application. And once we have this collection, this summary there, then the summary let's say helps us to understand what is the average usage of the equipment, what's the maximum usage, what is perhaps the lightest usage that we can find from the field. And based on this information, then we can set the specifications for the new product development. But still, this is very valuable to make it like that, because then our new product development would be based on facts measured from the field, representing the average customer usage within its range in a certain application. And basically we have there in the sales the same problem as we have there in the new product equipment. Because in the sales we need to be able to pick up the right product from our product portfolio to be offered to the customer. And how to know what is the right product for the customer use? I believe the knowledge comes from the analysis of that kind of thing. So how the other customers, for example, are using their equipment for same kind of application. And in service, based on the same approach, we can optimize the equipment maintenance and service actions. And there actually we can also utilize the individual's information directly. So there in service, I believe we are able to utilize both the statistical information, collecting the information from the entire fleet of the similar customer application cranes or equipment, and also we can do some actions based on the measurements made out of the crane or equipment under service. But I see somehow that these three areas are the most potential ones, for example, a company like Konecranes, what comes to the usage of the digital twins. Then we can utilize also the digital twins and the information collected from the equipment by our partners. This is definitely coming on many industries once the operations of different companies are more and more connected to each other. And in our world, for example, it could mean that once a crane is generating information from the real world and also from other data sources to the data lake, and the data and analytics is done there, then our partners can do a lot of actions in their operations if we can share the data with our partners easy enough. This is very important, because we actually pay something out of these things, and the payment is the activity that we need to do to give the information for the partner. If we can do it easily without any kind of extra load or burden, then the output that comes from here must not be, or it's not needed to be that high. But in the case, this is very time consuming to share the data with the partners. We have there a lot of ownership issues of the data. We have a lot of security issues and so on. I believe then we don't do it if the payment on that level, on our partners level, is not high enough. So like that, I would say that once the tools here in the middle come easier and easier to share the data, the more potential it is that we will find there, let's say, partners working with us, benefiting our information and also giving some value for us. Then quickly the challenges. Ville spoke already that we have kind of like two areas of the information available. And I believe this picture tries to illustrate this from our perspective. We have been servicing cranes from 1960s up to now. And then here you see that the lower part of this picture represents the cranes and crane components delivered by Konecranes at a certain time. And then the upper section here represents the cranes serviced by Konecranes but delivered at a certain time by our competitors. And it's easy to understand that the information available from our competitors' cranes or our own cranes, before we had the IoT strategy available that defined that what these devices need to offer for the, let's say, data analysis systems, was not complete. It was missing or it was incomplete information, fragmented information, the data quality was there not good, and so on and so on and so on. So we cannot say that this equipment over there was really fully, let's say, fulfilling the requirements of the DigiTwins. But up to a certain level, this was anyhow somewhat like helping us trying to utilize the information from there. So we could say that it was like digital shadow area. Once the most potential area here, the red one, where we have already the kind of like we are organized to get the data in the background systems, and we are organized there in the equipment to offer the data. Then we are on the best area, and this best area is now growing on a certain rate. And then we have the other like digital shadow area where we can get some benefits, but the benefits are not that high in here than on the best possible area. Then the cost of the DigiTwins are coming actually from many areas. The creation is costing something, the sensoring costs something, the data structure during the lifetime of the DigiTwin costs something. If we do part changes there, it's costing something. If we do modernizations and kind of like reflect the changes to the product structure of digital twin, it costs something, and so on and so on. And then we have the like savings on the other side of the equation. So in a way, all the time, and I believe this is one of the challenges, is that all the time we need to think about the return of investment and who actually owns it, which department, and so on. So this is something that is kind of like not hindering us, but before this equation is in the right balance, I believe we cannot go so quickly. The update of the DigiTwins, I spoke already about this, but this is one challenge. The critical area is coming later on, so the benefits are mostly in the future, once the cranes are kind of like already run almost through their life cycle and service life, and this may be quite long time, from 10 years to 30 years. There the best benefits are coming, and so long we need to update the DigiTwins properly in steady systems and taking care about all the service parts changing and other, let's say, DigiTwin healthcare actions properly. For sure, one challenge there. We have a culture to utilize the traditional data. We should change. We should start to use the new data. For sure, the culture change is kind of like a challenge. We need to do it. There is a lot of potential in here, but this is also very hard to break, because this is how we are used to live. Our processes today, they are running like for sales like this, for service delivery like this here, for material delivery like this, for product process like this, and the digital twin is today in the side. It's a challenge to get it to be as an integral part of those natural processes that we are running every day in our business. Then a couple of other challenges. Our customers are competitors to each other sometimes, so they are a little bit careful with their data. They want to be sure that their data is not used by their customers, so we need to be able to guarantee this 100%. The data creator is not always the one who gets the benefits and wins. For example, in the ecosystem situations, we need to take care about this. The legal aspects are there, like spoken in the morning time. And we have some security things there also as a challenge all the time. The bad guy is there waiting for us. Another one. Third one from another angle. There are quite many. We need to get protected. Okay, but as a summary, so we have the potential against the challenge. The challenges are there, the red area. And then we have the potential, that is the green area, where we are going with the digital twins. The answer is fairly easy. We have quite a lot of support for the green area. We have better and better network connections. The investment that is done to get these DigiTwins and our IoT business to run up is huge. I was counting from one statistics that here, for example, the investment of different industries was more than 550 billion per year, and it's rising up all the time. So the support that the green area gets is bigger and bigger every day. The new level of computing power is reached each and every year. The costs are going down. There are companies who are offering turnkey software solutions to manage this. Business to customers or consumers is growing up also on this area a lot, and there we have a big volume. This is going to help the business to business solutions for sure. And more we are able to read about the success stories. So there are breakthroughs, and for sure those are supporting and encouraging the rest of the industry to come to the same direction. That's all from my side today. Thanks about your attention.
Thanks, Matti. You kept your promise. We are not ahead of schedule anymore. Okay, but there's still some room for questions. I didn't dare to actually interrupt this presentation, so it was that much interesting. But I suppose there might be some Some question for Matti. Is it too late already?
One question about the success stories. Aren't there enough success stories yet? Or so are we missing those? Is anybody able to show the money?
Somehow I believe that there are, but they are touching the companies so much if they come from other industries. But once our competitors come to the area, I believe then it touches our strategies, our management, our operations, and like that we are like forced to go. And I believe this day is also closer and closer.
I had just one short question about if I've understood correctly that your business or maintenance is kind of regulated business, so it kind of have certain intervals the cranes have to be maintained. What about this predictive maintenance or these digital twins? Can they actually kind of postpone these maintenance activities by regulated activities?
I believe that the regulative part of the business is like 1/3 of something like that, and then there like let's say non-regulative area is like 2/3 or something like that. And first of all, I would say that we cannot overcome the regulations with these digital twin tools and approaches, but it means only this 1/3 of the business. 2/3 is still the area where we are able to do and optimize as much as we want. And also for this 1/3 that is regulative, I believe we can do better work with the information that is coming measured from the field.
One short question in the end. Are these digital twins a must to survive in the future? Do you have to have these digital services enabled by digital twins?
I believe that it's a must, especially if we think about the global competition. And if we think about the countries like in the Nordic and in Europe and in the Western world, I believe we are not cost competitive if we speak only about the hardware and its investment. But once we speak about the connected services, and if we do the connected services by a smart way, then we are kind of like building new platform for us to, let's say, succeed in the competition, especially once the customers are getting more and more, let's say, aware of the life cycle cost of their investments, not only the pure investment part.
Okay, thanks Matti for an interesting presentation.